Have you ever looked up at the sky and wondered, why is it blue? It's one of the simplest questions we ask as children, yet the answer reveals some of the most fascinating science in nature. In this video, we'll explore the hidden story behind the sky's color. From the nature of sunlight to how it interacts with Earth's atmosphere and the physics that shapes what we see every day. By the end, you won't just know why the sky is blue. You'll understand the incredible science that makes it happen. Let's begin with something surprising. Sunlight isn't actually just one color. At first glance, sunlight looks white or even slightly yellow. But in reality, it's a mixture of all the colors in the rainbow. Each of these colors travels as a wave of energy, and each one has a different wavelength. Red light has the longest wavelength, stretching up to around 700 nanometers. Blue and violet, on the other hand, have much shorter wavelengths, around 400 to 450 nanometers. Now, here's where things get interesting. When sunlight enters Earth's atmosphere, it doesn't just pass through unchanged. It collides with tiny gas molecules like nitrogen and oxygen. And these interactions affect each color differently. And that difference is the key to understanding why the sky appears blue. The process responsible for coloring our sky is called Rayleigh scattering, discovered by Lord Rayleigh. This phenomenon explains how light is scattered by particles much smaller than its wavelength, like the molecules in our atmosphere. Here's the crucial part. Shorter wavelengths scatter far more strongly than longer ones. In fact, the intensity of scattering is inversely proportional to the fourth power of the wavelength. That means blue light scatters about 10 times more than red light. So as sunlight enters the atmosphere, blue light gets scattered in all directions and filling the sky from every angle. And that's why no matter where you look during the day, the sky appears blue. But wait, there's a twist. If violet light scars even more than blue, why isn't the sky violet? It's a great question, and the answer lies in a combination of physics and human biology. Technically, violet light does scatter more than blue light. So in theory, the sky should appear violet. But three important factors change the outcome. First, the sun doesn't emit as much violet light as it does blue light. So there's simply less violet available to scatter. Second, our eyes are not very sensitive to violet wavelengths. The photoreceptors in our eyes, called cones, respond much more strongly to blue light. And third, some of that violet light is absorbed in the upper atmosphere before it even reaches us. So when all these factors combine, our brain perceives the sky as overwhelmingly blue, not violet. It's not just physics, it's also how we experience light. Now, let's talk about one of the most beautiful sights in nature: sunsets and sunrises. Why does the sky turn red, orange, and gold during these times? The answer lies in the path sunlight takes through the atmosphere. At sunrise and sunset, the sun is low on the horizon. This means sunlight has to travel through a much thicker layer of the atmosphere compared to midday. During this long journey, most of the shorter wavelengths, blue and violet, are scattered away before they reach your eyes. What's left are the longer wavelengths, reds, oranges, and yellows. These colors scatter less and continue traveling directly toward you. The result? A sky painted in warm, vivid hues. It's the same scattering process, but viewed under very different conditions. While Rayleigh scattering explains the blue sky, it's not the only process at work. There's another type called Meade scattering. which involves larger particles like water droplets, dust, and pollution. Unlike Rayleigh scattering, Mie scattering affects all wavelengths more evenly. That's why clouds appear white, because all colors of light are scattered equally. And when pollution or haze is present, the sky can look gray or washed out. In a way, the color of the sky is like a portrait of the atmosphere above us. Clear air gives us deep blue skies, while particles and moisture can completely transform what we see. So the next time you look up, remember, you're not just seeing a color, you're witnessing physics, light, and the atmosphere all working together in perfect harmony.